So this will be a 5-minute intro for the following event series, 1116 lamps. Following that, Charlie will give a lecture about sticky materials. This intro and the following lecture will be recorded and made available on YouTube. Over the next 5 months, we will be exploring various types of situations in 5 different municipalities. The first challenge comes from Talsi, and it will be about street lamps. During the project Flock of Ideas, our ambition is to make design and idea competitions about topics that are rarely investigated through the medium of design competition. Problems that we have chosen are often complex, tangled, or hard to define. Therefore, competitions are rarely used as a method for seeking solutions. Today, we are starting with the situation in Talsi. During the next year, there will be 1,116 street lamps that will be replaced with a new and more efficient LED lighting within the territory of Talsi municipality. Taking the size of the lamp in account, this makes roughly 300 square meters if laid flat. Predictably, in Latvia, the number of lamps to be replaced over the following 2 years is at least 10,000. This is unusual material to work with. It requires careful investigation, and there are many approaches that can be used when creating a design with these kind of elements. In order to get a common knowledge about the topic, Talsi event will consist of the following. Today, Charlie will be giving a lecture about sticky materials, and she will be sharing her experience with recyclable materials and working with them. On 18th of January, there will be a workshop in Talsi Youth Center where 15 to 25 members from youth organizations from Talsi will define desired qualities and potential locations for the competition. And their work will form a part of the competition task. On 19th of January, in Ertur Design faculty, students from different fields of studies will be exploring materials. Students from various fields will be examining the lamp, its material, and all the components. Such lamp includes more than 8 different materials, and there will be we will be including engineering, electronic, and design and architecture students in this investigation. All of this will result in a competition, which will start on 22nd of January and end on 29th of January. Participants in the competition will be asked to submit 1 to 3 images and additional text. 3 best proposals will receive €300 each. Once the competition starts, all of the base materials will be published on our website, Tandeems.com. This will include CAD drawings for the lamps, a 3D model, and additional documentation about all of the components that the lamp consists of. Results of the workshop will provide additional information on the possible sites and also provide qualitative exploration of the components that the lamp consists of. Submission of the works will be open from 22nd of January and close at 8 p.m. on 29th of January. I'm happy to give the screen back to Charlie, and I'm really grateful that she agreed to give us a lecture and also to be expert, helping to formulate the task and giving some insights about her experience working with these kind of materials. So I will stop sharing and give the place for Charlie to continue.
Hi, everyone. Thank you so much for the introduction, Carlos, and also for the invitation. I'm super excited to be part of the lecture and part of the workshop series and competition, as this is also a way for me to touch base or return a little bit back to Latvia, where I've lived 7 years ago. And it's always great to come back and get in touch again. I'm gonna now share my screen and start with the lecture. We have a bit of time afterwards for questions, so yeah, please take note and join the discussion afterwards. The lecture I'm giving is titled Sticky Materials, and it is the introduction lecture to a block of ideas and to the workshop on more than 1,000 street lamps, which are going to be investigated and explored over the next week, and also throughout the competition. And in this lecture, I want to focus on materials, on the material landscape we inhabit today, the urgency of material reuse, and the possibilities to approach material reuse. I approach this subject from being an interdisciplinary designer and material researcher. I don't have a background in architecture, but mainly in material research and interior and landscape design. So this is where different knowledges and skills come together in this practice of materials. So I'm going to try and give you an insight into my experience with materials, which might be helpful in looking and perceiving these lamps that are going to be worked with in the next week. I mainly focus in my work on material culture in the context of the planetary resource shortage and climate crisis. I mainly do so through my own practice with materials, installations in public space, but also through workshops with different parties, from municipalities to young designers, but also throughout academies and universities internationally, such as the Rotterdam Academy for the Built Environment, as well as the TU Vienna in Austria or HGK Basel in Switzerland, but also most recently at the Arts Academy in Latvia. A few examples are what you can see here. So it's different material experiments, as well as public installations, which all comprise a design and workshop practice together with sticky materials. But now the big question in this lecture is, of course, what are sticky materials? What am I going to be speaking about? And this is something I want to explain by an example of an unsticky material, or actually, to be clear, a range of unsticky materials, which are all comprised in the Fairphone, which is a phone that was developed by a Dutch designer in 2013, the Fairphone 1, which is one of the only phones that can really be decomposed and disassembled into each and every single separate component that it's made of. And all of the materials that this phone is made of can be taken apart and singled out. In this way, it becomes possible to reuse and recycle every single material that's included in such a phone. And this is a little bit what I mean when I talk about stickiness. When you take something apart and it can become again its own material, then it's very unsticky, it's clean, it's separatable, it still remains its own component. But this is not so much true for what most of us have in our pockets, an iPhone or another smartphone. Most of the materials and components in such a phone cannot be taken apart, and they are so hard to separate that mostly they end up in a landfill or on a scrapyard, because they are so sticky they cannot be taken apart. Sticky in a proverbial sense, they are just so interwoven material-wise that they are so hard to take apart that they become trash. And this is one of the main issues we are actually challenged with when we're thinking about reusing materials. If we now bring this into the construction industry or into the built environment, when we look around us, what surrounds us, and we translate that unstickiness and stickiness into this context, we see that a material component like a brick, for instance, really is something that we can describe as unsticky. It's something that we can imagine reusing again and again and again. But when we think of it in a wall, and mortar and bricks combine to a brick wall, what we see happening, or what we've seen happening from the 1940s roughly on, is that mortar got so binding and sticky that it's easier to take apart and break a brick than taking apart the mortar that binds the brick together. So this is something we see happening across different materials, and the material culture that we surround ourselves with is that the ways that materials are combined and components are literally stuck together, it makes it incredibly hard and mostly impossible to take them apart again, which leaves us with an overabundance of sticky materials, which you can see on the right side. And this is also the material I want to talk about today mainly. It's a material that I focus mainly on in my practice and that I researched a lot, which is construction rubble. It's a mixture of materials. When we take apart a building, we mostly do this with a breaker and big infrastructural machines that allow us to break apart these buildings, but not separate them into separate materials, but we break them into chunks that are comprised of sand, stone, glass, gypsum, concrete, steel, and all of the different elements that we glue together to a building beforehand. And now let's think about why this is problematic, that we have this abundance of materials. One of the things that we see happening is that since 2020, or actually 2020 itself, was this moment in time when globally there existed more human-made mass, so things that humans made and composed, and it would exceed the living biomass on the planet. So the living and the natural matter was exceeded by, you could say, the sticky materials that we produce. So today we have more sticky materials than virgin materials. And if we look ahead towards 2070, we can see that we will slowly run out of more and more virgin materials, fresh, natural materials that we compose and produce building and production materials from. And we understand that at the current rate of industrial growth, we will soon, around 2070, start to run out of materials like iron ore, for instance, which is today very important for the production of steel in the construction industries, and we rely on it largely. So what we see happening, and what this urges us to work towards, is to get familiar and understand that sticky materials will become the new virgin materials we will be working with. Another reason that really requires us to expand in our vision and to understand other and alternative possibilities of building, of constructing, and of producing is that through a 2-degree rise of the global temperature, major unpredictable natural catastrophes are going to be unavoidable. This is what climate change is about. And the carbon emissions and the energy consumption that we rely on through industrial production is at the moment largely working towards this 2-degree rise in temperature across the globe. And we do have to see how we can find possibilities to drop this productivity and energy consumption. So these are all reasons why there is a true urgency in working towards other material practices and ways of thinking of materials. In my own work, I am really looking into the approach to these materials, and mostly this is trying to get to know them and becoming familiar with them and looking at them very closely through experiments and testing to understand how they work and what their true potential is. Because materials like construction waste or material waste that comes from cities, such as street lamps that are at a certain point outmoded and removed, it needs us to take a closer look and experiment with them to understand them properly and see if we can find a use and application for them. I'm going to show now 2 projects which show 2 different attitudes and approaches to materials. One of them is a 10-day workshop I organized at the TU Vienna together with Thomas Amann and Estelle Julien. This was a project that was largely supported by the LINA platform, a European educational platform that looks into new architectural practices and possibilities. And we guided this workshop together with the architectural students in the master at the TU Vienna, and together with 14 students, we explored the region around the Wörthersee, a lake in Austria, to understand what local material streams are active in this region and could possibly play a role in new architectural materials. And when I say material streams, I'm talking about natural material streams such as clay, soil, sand, and different kind of biological materials like hay and straw and so on, which can all be used and are very well known in vernacular material practices and building methodologies. But I'm also talking about what we understand as waste streams to date. And this is something that I really do not like to use, this term of waste. It's not waste materials that they are. It is unwanted materials, but materials nonetheless. And these kind of materials that are byproducts from industries, and they have no application, such as building rubble, which is globally present and also was present in this region, and things like stone crushing dust, which occurs when you are, for instance, in a stone quarry, just as this in the Austrian countryside. When stone is crushed and machines are cleaned, what you get out is a lot of dust. 24 tons are produced per hour. So you can imagine it's a lot of dust. So we looked at all of these materials and tried to map them across the region to understand, okay, what resources do we have? And the students started from there and started to explore their properties through tests like the bottle test, for instance, where you can read what sediments are contained in certain soils or materials. And from there, we started to explore different techniques of applying these materials in architectural materialization. So we looked at different possibilities such as rammed earth construction, which is a construction you might not know, so I want to explain it briefly. It's construction where you use soil and clay in order to compact this soil and this clay to load-bearing and rigid walls. This is a practice that requires a lot of clay to stick together the walls and the material. And we did different tests to explore rammed earth walls, floors, and bricks, but also plasters, as well as ceramic glazes through different herbs and vegetation that is present in this region, as well as different dyes for textile and pigments to understand how can we make use of these materials. Among other materials, we also used spent brewer's grain because there are a lot of beer breweries in the neighborhood of this region. And the grain that comes out of these breweries is also one of the largest waste streams that we could find. So we also tried to apply them in compressed panels, which are good for sound and heat insulation. So we tried to also compress these fibers into panels to understand how we can create also an interior architecture material palette. And throughout 10 days, the students made several material experiments, trying ratios and recipes from material manufacture. And here you can see the final outcome, which is a library housed in this part of Austria at the Wörthersee, and is accessible to the local community to understand what materials are present. So for instance, on the right side, bottom corner, you see all of the raw materials, from sheep wool to different vegetation, to the different sand and clay contents, and wood chips and wood waste from the wood industry and forest industry in the region. And on the other side, you see the different pigments, the floor testing, as well as the first tests of compressed walls, which were in this case very successful, and we had up to 10 promising recipes for the students to succeed with, and also for the local practitioners. So the people that lead stone quarries, natural stone quarries, and are active in the forest industry, as well as in agriculture around that region. We made we connected a big network of players within these fields who had no idea that all of the materials that come out as byproducts or are considered waste out of their industries could play such a big role in architecture. In this way, we built further networks which now help the students to continue their work to develop actual new materials from such an experimental starting point towards the possibility of a real scaled up material. So you can build one building and many from such a material. So what you could say is that the students really developed also a local image and visual appearance to the local materials, both waste and natural material streams can offer in such a location. And what this project shows is how materials that are considered waste and that are considered sticky are analyzed and understood, and their properties are explored and analyzed. And we have a real example of how they could be reused and reapplied. And this way people can see and understand and slowly shift also their idea of what an architectural material can be. Because this is also one of the main issues that we see in reuse, that it is such an unfamiliar image or vision or look to what things feel, smell, and scent like, that it is very hard to imagine and to believe in such a possibility, and that it can be something that stands upright and is as rigid and as strong as the constructions that we are very used to in steel and glass today. From this material research, I want to go further into another project, which is called Soft Rubble. And this project is much more a material research into one particular material. Again, the material of construction waste and building rubble, which you can see also there in the background in heaps. And what this research project in particular looked at is how you can take one of these waste streams, one of these unwanted materials, and try and find a way to purely construct with it, and find new ways to construction with it. So what you can see here is the development of a construction system that relies on heavy-duty tarpaulin bags, which have a specific sewing pattern. so that when you fill them with construction waste that is crushed to a particular size, they start to interlink and lean into each other in such a way that you can fill them up to 30-meter heights, and they become load-bearing and freestanding construction elements. What you can see here is the first prototype, which is a wall segment, which includes a window opening and a seating element. And here I also want to show a few images of the building workshop we conducted together with 5 participants. We could construct the prototype within 8 hours of filling. And we used 13 tons of building waste to do so. Now let me quickly see in my notes. What is important to mention here is that this construction system largely relied on one of the main qualities of this material, which is its compacting qualities, which means that if we fill this bag with all of this material, the longer these bags are standing and this wall segment is standing, the more of the finer dust and grains trickle down within the bag, and the material compacts as all of the gaps between the larger chunks of rubble are filled with smaller pieces. And this makes this construction rigid and firm, and allows it to become a very stiff bag, so that you in a way could put, for instance, a knife into it and tear the bag, and it wouldn't, such a hole wouldn't allow the bag to rip and to collapse. But as the material is held together by this membrane and of the tarpaulin, it stays rigid. And on the other hand, while it stays completely rigid, it can just as easily be emptied again, and the material is not sticking to each other, but it can be reused again and again. So while we have a rigid freestanding system, it is also a porous and adaptive construction system. So while I started with one of the materials that you could say is one of the stickiest to work with and one of the most difficult materials to get a hold of and to reuse, it becomes much more unsticky in the process and allows you to adapt structures that you're building. Now, this construction system was tested on a furniture and pavilion size scale. From there, it's developed also into a furniture series. And from there, you see that through this experimentation, we can understand how important the full body experience and the touching and the feeling and the experimentation in a hands-on manner is in such materials. And now looking at the kind of relation between these two projects of soft rubble and the material library, you can see on the one hand how the material library really looks at how materials can be reintroduced into existing vernacular means to construct and to build and to design, such as rammed earth or earthen plasters, clay plasters, and so on. Soft rubble is really a very experimental approach to finding new ways to build, design, and apply materials that we have discarded as waste streams so far. And from these two projects, my practice begins and evolves to become a practice that really searches how materials can be reapplied in practice. And you see that it's always connected to a hands-on approach and a finding of recipes and manuals that allow designers, architects, planners, people that are active in municipalities to get refamiliarized and to get in touch again with a material itself. Because only through the touch and only through the experiment, we can start to understand what these materials are, and we learn about their potentials, and in the end we find the value that they could possibly have in our future constructions and future plannings. So this was a small insight into my practice, which largely is concerned with sticky materials. And I would now open the floor for questions. I think I will stop sharing full screen so I can see you again.
Thank you, Charly, so much. I think it was exciting. And yeah, for everybody who maybe missed the beginning, so this lecture was recorded. We will upload it on YouTube and also publish it, so it's possible to see it later on. I just have a small comment on the lecture, which I find very interesting. Before we open the floor for the questions, one thing which I found really amazing is that the materials that Charly worked with are such that most of us don't even consider a material, like a dust or a rubble. And there's such a fantastic opportunity in this because it widens the possibilities of design instead of decreasing. So that was something that I found really fascinating. Please share any questions if you have. You can raise your hand or just speak. In case if there are none, I have some. I think it's really interesting in terms of these kind of unsticky and sticky materials, these kind of two categories that you mentioned before. And in one case, you're working with a material which is well, it's a dust, it's a byproduct. I would assume. Another case, it's really sticky material as a concrete, which is a result of this kind of design approach. And well, knowing that our competition is coming on about the street lamps, which are like these, we have already tested it. This is not a sticky material. You can't take them apart. However, they're going to be replaced with the LED lighting, about which I'm not so sure. It might as well be a sticky material. And in regards to that, I have a question to Charly. What is your feel about design in general? Is it moving more towards sticky materials or unsticky?
I would say it's a very good question. I would say that we will unavoidably move towards more sticky materials because we will be facing projects like the one of the competition much more often, of how can we take things apart, and we will realize that a lot of parts we will not be able to take apart again. On the other hand, we will face the fact that there are not gonna be so many virgin materials around, fresh materials that we can start from scratch with, and we will start to explore what sticky materials, how they could be used and how we can work with them. So sooner or later we will lose that feeling of them being sticky materials, but we will realize that actually these are becoming the new virgin materials, and we will begin to work with such material composites like construction rubble, just as if it was a raw material like clay or sand. We will just understand that they have different properties, and actually those properties are also superpowers and great qualities. We just have to change the way we apply them.
Are there any more questions?
Hello, I have a question.
Yes, please.
You already mentioned that before you reuse the materials, you analyze their properties and test them. Could you tell about methods more? Do you take them to the laboratory or it's some kind of on-site testing? Thank you.
Thank you very much for your question. It always depends a little bit in which context you're doing the analysis. Mostly I'm working together with students in order to for them to get in touch with the material and for them to experiment with it. And in the case of the workshop together with TU Vienna and the architecture students, we analyzed all of the different materials which were raw dust materials through their weight, through their haptic qualities, through their appearance, and also the way they react when you mix them together. And the reason why was because they are architectural students, or mostly I'm working with design or architecture students who are really interested and curious about how you could apply these materials visually or construction-wise. So mostly it is about the visual qualities or the applicative qualities of these materials. So we mainly do hands-on experiments and testings with the materials. But then when you have this stage of experimentation and you have finalized all of your first tests like we did, we made around 220 samples altogether for ceramic glazes and different compacted earth bricks and rammed earth samples, for instance. So altogether we made 220. And then we selected 10 promising directions of where to go. And from this moment on, another workshop picked up the work that did then further testing and went deeper into the tests. So what they did then is refine the recipes we used and understand what are when does a brick start to become brittle, or when does it become so firm that it breaks when it dries. And these kind of things they analyzed. And after this workshop, they came up with around 5 very promising stages, which then can be detailed further and sent into labs for compression tests and so on. And this is then a stage when you start to understand if a project is scalable. So you have other building examples like Atelier Luma, for instance, which is one construction project where earth construction was tested locally. And the way to scale up such a production or material use is then to send material tests to a lab and to bring them in the context of a compression test or a breakage test that you drop it from a certain height and so on. So these are ways to both analyze the qualities, but also test them. Yeah, I hope this answered your question.
Yes, it answered very well. Thank you.
Thank you.
Hello, I hope you can hear me. Thank you,
Yes.
Charlie, for the lecture. I wanted to ask you, you have been working on a lot of materials with building rubble and probably a lot more. Is there any like already in use, that some businesses or like are they usable already? Like they have a patent or some other way for using it? Or is
Are you
this still research?
are you speaking about building rubble in particular?
For instance, yes, like the building
Yeah.
rubble.
Yes. So building rubble is finding more and more a way back as we are riding this wave of material experimentation across architecture and the construction industry. But to start from the basis, before this idea of material reuse, building rubble is still and used to be much more used as a terracing material. So when you level a landscape for infrastructure work or road construction, building rubble is the base material that this is made of. Or you have a stone quarry or a clay pit or large landscape, holes in the landscape. These would be filled with building rubble as a filler material. But in this case, it's only used as a secondary material, and we create it in such abundance that we cannot use up. We cannot fill enough holes with this material to call this a proper solution for reuse. So we have to find other possibilities. Otherwise, we will end up in landscapes that are not made of green, but made of rubble. And this is also the reason why this experimentation continues to be so important and also interesting in the architectural environment. So there are a lot of experimentations and applications already. So what you see in rammed earth construction, the test that we also did, is that a large part of the natural gravels that would usually be used in such a compacted monolithic wall are being more and more replaced by such building rubble. So the building rubble becomes the gravel in such construction. And it starts to also be introduced into bricks and other materials. But it's a very slow road to this. And the reason for this is that it's a very uncontrollable material. So with sand, for instance, you know exactly how it reacts. But because construction rubble is, it has a different mixture in any place where you go. It depends a little bit how buildings are constructed. In Switzerland, for instance, you have a lot of stone construction. In Latvia, there is a lot of wooden construction as well. While, of course, globally, we have a lot of concrete, but the mixtures, they always change a little bit and adapt. So that this material, there is no one material stream you can speak of. And this makes it hard to understand the properties of the material and know, for instance, how it reacts to compression in a road or in a brick. So that makes it hard. But the applications are growing and the trust in that material as well, and the methodologies to understand it enough to apply it. I hope that could answer your question.
Thank you. Yes, more or less. But as I understand, your main interest is about rubble. You have developed probably a lot of materials, and wanted to understand that this research have really, like, how is it paid off already? Do you have like material that you can show to the buyer and they are willing to work with it? Are they like possible to work with it already?
Yes.
They're like, okay.
Yeah. So one project that I mentioned is that of Atelier Luma, which is a renovation project in the south of France. And in this renovation project, bioregional material streams and waste materials were analyzed to understand if they could be applied in the renovation of this building. And in this material research, at the very start, I was involved in understanding the construction waste streams that are active in this region and understand what the particularly local mixture is consistent of. And in the end, this particular material was also introduced into the rammed earth construction inside this building. And all of the interior walls were made with a rammed earth mixture, which to a large part contained this material stream. So they have a very specific mixture there, which contains quarry dust as well as construction rubble. So two different waste streams, which are also very specific and look also like the local stone that you can see. It's a very light mixture of rammed earth, and these are materials that are now in application. The building has been constructed and has been finished last summer. So there is one building that has been finalized, and throughout the construction and the realization of this building, the local architects had to work a lot with the local policy to adapt the policy and prove that this way of building is a possibility of construction, and to shape the first case study of a rammed earth building with construction waste content as well as quarry dust, which is also a waste stream, that this is a legit possibility of building. And such a case study, such a precedent, makes it then possible and easier for other possible projects to apply the same method and to deepen and expand this kind of research and material use. So these are, the instances in which, there are successes from this material research, and you can say there is a true potential there, and the practice is expanding, every day.
That's good to hear. Well, thank you for your answers, and wish you many more realized projects.
Thank you very much.
Okay, are we done with the questions? I think it's a great moment to end with also this kind of example of limitation of the regulations. Well, the regulations is often one of the biggest challenges when working with recycled materials, and at the same time regulations are requiring for this kind of recycling again and again. So there are only few of those people who are ready to sacrifice their time and energy to fight and to break these things. And today with us, there was one of them. It's Charly. And thank you very much for joining us today. And thank you everybody who were here. And I don't know how to finish this in Zoom, but you should upload because I think she said some very inspiring things. And thank you everybody. Thank you, Charly.
Thank you very much. Thanks everyone for listening.